I do have some time allocated this session if people do have questions about their safe system assessment that they're currently undertaking. If they've come up with any issues or they want some clarification on something, I can certainly answer that. Feel free to type it in and Kathy will relay it to me, or if you want to just talk it through, just hit the raise hand button and then we'll unmute you and you can talk to us, or we'll give you the ability to unmute yourself and you can talk to us. So I do have a little bit of content to cover in this session, and I do want to answer any any questions you've got around safe system assessing, general policy, or the like, and we'll go from there. Okay. Oh. Oh. Are you still there, Kathy? Did I just get logged out? No.
No, no, we're seeing everything, Ken. It looks like you were going to show us a different program, though. That's good. 2 for 1.
Well, I just I thought Zoom had kicked me out for some reason, but no, we're good.
Yep.
Policy guidance, the general topic for today. Final module. It's a bit sad, actually. I'm enjoying this group. Lots of good questions, good interaction, and last chance for you to count your wallies. So really today is trying to wrap this all together to try to understand also a little bit about the benefits of safe system assessments and why do we sort of do that at the end? Well, we wanted you to get to understand the process and then talk about the benefits, and we want you to go out and promote safe system assessments as a technique to improve safety across existing roads, designs, or the like. And so we're going to arm you with a few bits of information about their evaluated effectiveness, and then you can talk to people about those. And hopefully you'll be out there helping them and doing safe system assessments for them, for their projects and or for the existing road environment or whatever it is. So we want to talk about, well, where is it best to do safe system assessments in the life cycle of an infrastructure project? Or the life cycle of a road for that matter, and explain the differences between safe system assessments and road safety audits. And that's a very common thing that comes up, which is you say, well, perhaps we should consider a safe system assessment for this project. And they say, oh, well, we're going to get a road safety audit done. Why would we do that? Like, we don't need another thing. They're just the same, aren't they? And I want to show that they're slightly different and they serve slightly different purposes, of course. Now, Max in module 1 showed you this little map, and I'm not sure how much time he spent on it, but I do want to briefly go through this. I think it's important to understand the traction that safe system assessments are getting and the sort of mandated requirements, because that's a pretty powerful thing for you as a certified safe system assessor, which is what you'll get a certificate that says you've successfully completed a safe system assessment course, and that's for most jurisdictions as good as it gets in terms of qualifications to be able to say, yes, I can undertake a safe system assessment. Look, I have a successful completion certificate. But you as a safe system assessor and talking to people about what their requirements are from the road authorities in order to do safe system assessments at different stages. So Queensland has mandated it in the TMR policy. Sorry, I went back a slide, still only on one wally. Queensland has mandated it in the road safety policy for TMR projects, okay? So it's going to have to be done on those TMR jobs. For local governments, it's still up to them as to whether they want to do it, but we're starting to see an emergence of local governments requiring it or putting it into their road safety plans or setting up policies around when it should be included. The newest New South Wales Road Safety Action Plan requires safe system assessments at feasibility, functional design and detailed design stages of all Transport for New South Wales infrastructure projects. So that's pretty exciting. And that's been released and signed off. And that's up and running. So there should be quite a bit happening in New South Wales around safe system assessments. New Zealand's actually just come out with the safe system audit guidelines, which is a mashing of the two things. So I sort of put them to the side at the moment because it's a bit of a different process. Tassie's getting on board, certainly doing safe system assessments for major projects, nothing formalised and documented in terms of when they have to do it. Victoria's got some specifics and South Australia's got some specifics on projects that trigger, and I will talk you through those in detail. I think they're interesting ones. And the territory is integrating it into contract specifications. You know, safe system assessment must be done along with that. And Western Australia's, well, it's like a different country, really. They're doing completely different things. Put a line down there. Okay. So what sort of benefit do we get out of doing this safe system assessment? I mean, it's another process. Do we really need to add more processes into infrastructure projects and the like? Only if they're going to add value. So what this graph shows is an evaluation, an independent evaluation of 35 safe system assessments on major infrastructure projects. And I'm talking big, like we're talking, you know, town bypasses, we're talking major duplications of outer suburban arterial roads, freeway upgrades with, you know, extra interchanges and the like. So big projects. And what they did is they used a crash prediction model, and they used a 20-year period. And here we've got fatal and serious injury crashes that they predict over the next 20 years in these areas where the projects are happening. So the first one here is saying, if no project happens, so nothing is built, they don't do this upgrade, they leave the existing road as it is, and for the town bypass one, there's no town bypass, they still continue to put all the vehicles through the town and the like. How much death and serious injury in these 35 projects in all of these areas over the next 20 years are we expecting? And the model spat out 344 fatalities and 7,900 serious injuries. So each of these projects then had a design done, and most of them, the designs that were subject to the safe system assessment were at a, what am I going to say? They were beyond concept, preliminary stage designs. They reference designs often for big, you know, design and construct style contracts. So the reference design. So they've got a bit of meat on the design, but certainly not detailed design. 32 of them, I think, have been subject to a road safety audit. So there had been a degree of safety independent scrutiny on them already. And you can see there that if they built exactly what these designs were before the safe system assessment process, this brought the crashes down to 268 fatalities and 6,700 serious injuries in those 35 project areas over the next 20 years. So then the safe system assessment was done. And the safe system assessment came back with recommendations, as you are doing with your safe system assessment. So it said, okay, we've seen your town bypass design here, and you know, we've looked at this and we suggest continuous barrier systems in these areas. We suggest that this cross intersection, be blocked off and have an acceleration lane, those sorts of things. So some significant changes. Now, if they took on all of those at the highest level, so if there was multiple recommendations that contradicted each other, which you often do as a safe system assessor, you say, do this, and if you can't do that, you could do this. They took the one that would give the biggest bang for or the biggest lives and serious injuries saved. It got it down to 167 fatalities and 3,890 serious injuries over 20 years. Now, what the project team then did was they got all of these safe system assessments, so 35 project teams. They sat around, they said, well, okay, what can we do here? Can we do this one? No. Can we do this one? Yep, we can do that. We'll make that change. Can we do this one? Yep, we'll do that. We can't do this one. Instead, we're going to do this. Okay. So then they came up with this sort of agreed project that was moving forward. And that went back up to 227 fatalities, 5,298 serious injuries. Okay, so this tells me quite a story. And I'll just briefly take you through the story it presents to me. You might have other insights. So the first thing it says to me is that the projects and the designs coming out of the big design houses, pretty much just following standards and guidelines, improves road safety. It improves things. So we can't really argue that, well, sometimes we can, but not often does it go the other way. And by doing $1 billion worth of upgrades, you make things worse in terms of road safety. So that's one thing to just acknowledge, and that's what that is. The next one is that we got a lot we can do, don't we? We can do a huge amount more in terms of reduction in death and serious injury with these projects, if with what we know about and what the assessment shows. The next interesting one to me is that, why do we go back up? Well, we go back up because of people, being concerned about this idea, maybe thinking that the community might not accept that. Maybe it's, well, we'd like to do that, but there's a major cultural heritage site there, and so we can't do that. Or maybe it's, well, it's just, we don't have, that's going to cost a lot more. We don't have that in the budget. There's a lot of reasons for that going back up. But this difference here, that is the value of a safe system assessment being undertaken, going through the process, because they are changes that can be made within these projects, and they do make them. So that's a pretty significant sort of win just by going through this process. So that's quite interesting, isn't it? The other one I find fascinating is this. Like, we're going for 0 death and serious injury as our aspiration. We're doing a safe system assessment. Why are we not seeing that as 0 if they did all these top things that the safe system assessors are recommending? Are we going to eliminate death and serious injury? Well, the answer is on this that, first of all, I think it shows that the evaluation and the prediction model are probably realistic. And when you dig into, well, what is this prediction model spitting out? What's going on with these? These are a whole lot of complex crashes that we don't have really ways to treat within our toolkit at the moment. So what we see a lot of in there are motorcycle crashes on high-speed roads. And, even when we suggest the motorcycle underrun protection and things like that, we're still seeing that they cannot handle the 100 km/h crashes. right? And there's abrasion issues, and there's a whole lot of things that come out of that. So motorcyclists, we're seeing under the prediction model, the high speed, inappropriate, intentional driving style crashes. Okay, they're not being able to withstand those within that. So we're seeing sort of some of these anomalies. But what I sort of take confidence is that we're really looking at the infrastructure here. Now, we do dip into in those other elements of the safe system, talking about can enforcement be conducted safely, and can we, is there anything we can do to enhance that and the like. But that is such a, we're looking at an isolated part of the network, and those are big picture, sometimes national, like vehicle standards and enforcement, strategic statewide efforts and allocation of funding and how resources and all of that. Like, it's complex sort of stuff. And our recommendations in this project aren't going to be making those big, wide scale changes. So that all needs to come and play its part. So you kind of say, well, this is almost the limit of what we know the infrastructure can do with the knowledge we have today. I hope we're able to continue to bring this down as we innovate, we come up with new road treatments, we come up with new ways to design intersections and do all these other things. But we need the vehicles, we need the vehicle technology, we need the policy support, we need legislation improvements, we need people to continue to work on some better road use practices and all of that for us to see that come down. So, I mean, we can take this as a huge win of just going through the process. And we can take this one as a big challenge for us to get more funding, more cultural acceptance in industry of new practices and alterations and the like. We can take this as an innovation challenge. Well, how do we protect a motorcyclist at high speed? Are there changes we can do to different bits and pieces? We take this as we need lots and lots of wonderful people in road safety. Probably expand that out up to here. Thinking about vehicles, thinking about people, thinking about enforcement, thinking about vehicle technology and everything like that. This gap between the designs coming out of the big design houses and what can be done, I want to see that coming down as well, because more people are going to get safe system assessments done on their projects. And it is a very sneaky Trojan horse of learning, the safe system assessment, because when a designer comes up with their road design and then you do a safe system assessment on it and you hand it back and it doesn't score particularly well, they want to learn how to get better scores. And they look at your recommendations and they look at other things and they try to understand, well, how do we do this? And all of a sudden, you've just got this wonderful learning opportunity for the designers, the traffic engineers, the project managers for infrastructure projects and the like. So we'll see that come down over time. Gee, I spent a bit of time on that little graph there, Kathy. Looks like 3 just bars there, and I've done a lot. Now, are there any questions at this stage?
Yeah, absolutely, Ken. Interesting commentary there. So drivers of trucks are not catered for with safety barriers. Heavy vehicles bust straight through the barrier. Not sure if their lives matter with the current system.
So that is generally true, that heavy vehicles are not catered for with barrier systems. You can cater for heavy vehicles with barrier systems. You just need to choose a higher test level barrier. Test levels go up to test level 6, which is a loaded tanker with liquid in it that is crash tested. So that's a massive vehicle with a massive inertia force. But the bulk of barrier systems put out on our road network are test level 3, maybe 4. So we're talking about a 2-ton pickup or up to a 10-ton truck at the most. So you're right. The road design for heavy vehicles and catering for heavy vehicles can be a challenge. We do know that heavy vehicles have less of a chance of leaving the road than passenger vehicles. The overwhelming majority of run-off road crashes across all of Australia and New Zealand are passenger vehicles. Like, just absolutely swamps any other vehicle type. But we do get these rarer circumstances of trucks, buses, and others leaving the road. So we need to sort of consider those. We need to consider how we roll these out. But I think we have great opportunity with buses and trucks to utilize some of what I was talking about down here with vehicle technology. Like, there is no reason a large vehicle should leave the road, even if the driver's asleep. It just shouldn't happen, because we have the technology to stop that happening, and it's just about deploying it. And the easiest place to deploy safety initiatives is in the workplace, and those are workplaces, and there's no ifs or buts about that. That is a workplace. So I think we've got great opportunity to have that as the first sort of major entry with vehicle technologies, and we see that deployed. And we've got a lot of advanced freight operating companies and trucking companies that have in-vehicle monitoring, and also lane keeping, vehicle platooning, and automation of the bulk of the task. So I think physically altering our infrastructure to cater for vehicles beyond 10 tons for the bulk of the network is practically impossible. However, catering for those at the highest risk scenarios, overpasses, bridge piers, where you're going to have catastrophic failure beyond, we have multiple deaths and the like, we can absolutely do it with high containment concrete systems and the like. And, if you get worried about them being too rigid for passenger vehicles, you can do double barrier system setups where you have your concrete bridge piers, say, protected with high containment barrier at close to the piers, and then you have in front of that a continuous wire rope system, and that rolls along, so a passenger vehicle will hit that. Then if a large vehicle hits the barrier system and breaches that and makes it to the concrete system, it doesn't take out the whole bridge and the like. So there's some specific designs you can do that really, best of both worlds. And we will see the vehicle technology, I believe, sort of make it so that small percentage that do leave the road currently really whittles down to next to nothing. Any other questions for me to deal with there, Kathy?
Yeah, a comment here just about the road designer is only one member of the project team. So there's the project manager, the client project brief, constraints, other inputs from other stakeholders, which influence the design in such a way that even at the earlier stages, it's not always the issue with the designers.
Yeah, I think that's absolutely right. And it is no easy task to design road upgrades because you have to factor in those things that be, as mentioned there from Paul, so you've got a huge amount of things to cover off. You've got to think about costs, your expectations of community, your requirements around that. You've got to think about deliverability of this. You've got to think about maintenance of it. You've got to then think about any environmental constraints, cultural heritage constraints. You've got, practical challenges associated with, trying to ensure that drainage works properly, and then, and the list goes on, doesn't it? So we, as safe system assessors, and we've got a kind of luxury of just being able to present safety issues and present recommendations without the burden of all those practical shackles. We very much do try in our recommendations to be as accommodating as that as we can, but not losing sight of the fundamentals of our role, which is to call this out. Now, one advantage we do have, though, is the production of a safe system assessment report, quantification, putting numbers to it, putting graphs to it. It can be very powerful for some of those stakeholders, some local councillors, politicians, directors. So they've got their competing demands, but you've got now an expert who's come in and who's provided quantitative evidence to show that more lives can be saved. So in the similar way that we see, the traffic modelling report comes out, and that's taken, oh, look, I've got a 50-page SIDRA analysis here that shows me, my level of service changes, and this is, So we've got now this report that does similar with safety and puts that on the table. So it can be powerful for the designer and the project manager to say, well, we need to address this. We need to do better.
I think back to this graph, how are the serious and fatal injuries calculated here?
Yeah, what a great question. So how does a crash prediction model work? Okay, so there's multiple ways to do crash prediction models. This one used the crash history of the area, and I think they used a 10-year crash history period, right? Then they took that and they put growth factors on it, and then they put growth factors over the 20 years coming up in terms of growth in vehicles, growth in pedestrian activity, changes in land use, and the like. Okay, so then they got a growth in all of this, and they equate that growth to a growth in the crash history. Okay, so they say, well, okay, we're going to expecting this many crashes have happened in the last 10 years. In the next 10 years, we expect that many crashes plus this growth, and factoring in a few other variables. Okay, so that's how they essentially get to the no project crashes. Okay. To then look at a design and say, well, what benefit are we going to get from this? So you take your no crash scenario, no project scenario, and then you look at the design and you use essentially crash reduction factors for the different treatments that have come in the design. So, you look at roundabouts and you've got a crash reduction factor of about 80%. You look at different splitter islands, about 40% crash reduction factor. So, and those crash reduction factors are based on macro studies or really big studies of 1,000 sites that had splitter islands put in. So, okay, maybe some of them, a few of them might have gone up in crashes, but overwhelmingly they've gone down, and you average that out and you go, well, actually it seems on average that it reduces crashes by 40%. So you're able to use those, and then you have to use a few formulas because you can't be adding your crash reduction factors. So if you've got a road and you do an edge line, and then you do audio tactile edge line, and then you do a barrier system, and a sealed shoulder, well, you take any of those in isolation and they've got their own crash reduction factor. You have to use a formula to essentially get diminishing returns on your more and more investments. And then that rolls out then to give you a new sort of crash prediction under these scenarios. So you do that, and then you do that for all of these different scenarios. I hope that answers it.
Does a 5% growth in traffic equate to 5% increase in crashes?
It depends. It can create more or less, and it depends on the road scenario. Where, like, if you've got intersections, okay, what going from next to nothing on the side road to still next to nothing at the 5% increase doesn't make big differences. If you've got multi-lanes, there's a lot packed into that question, and really for mostly each scenario you have to think about it sort of specifically, and that's kind of what they did in these. They did take a growth factor, but they didn't just blindly apply it to X amount of crashes, the X amount, goes to that many more crashes. It was done in the scenario. So to a degree, they use the methodology set out in ANRAM, the Australian National Risk Assessment Model, with some modifications.
Okay. Are you happy to get into more specific questions on people's safe system assessment?
Mm-hmm.
Okay. So referring to intersection values, got someone with a major road which is 12,000 vehicles, and the assessment takes in two intersections, one at 8,000 and the other one at 9.5. So do we go 12 plus 8 plus 9.5 equals 29.5, or 12 plus 8 plus 12 plus 9 equals 41.5? Either way, it's a score of 4. However, if it was a lower amount,
yep,
which one would you do?
So is this one intersection or multiple intersections?
2 intersections. Are you drawing 2 intersections here? Yes.
I am.
Good. Okay, great.
Okay, so what did we say? The main road has 12,000.
Yes.
And this side road has 8.
8. And the other one, 9.5.
So the way to do this, and we do have a fact sheet on this. If I was undertaking a safe system assessment on this, I would go safe system assessment 1. Well, matrix 1, matrix 2. Actually, I would undo that, because I would, well, that's pretty much right. I'm going to chop it up in a slightly different way. Matrix 1, matrix 2. So you actually do 2 matrices for this. And that way you add your 12,000 and your 8,000 and this one, and your 9,000 and your 12,000 in this one. And then they are your exposure scores, and you will then produce 2 matrices and 2 graphs with all of your, existing conditions and the like. And I just leave it at that. I don't try to create one end score for the whole project. Okay. So the reason that I do it like that is, and this is, our fact sheet tries to clarify this, but this is, the Victorian and South Australian government have said that these are 2 legitimate options to do it, as a way to do it. But the reason, no, not that one. The fact sheet is actually how to do a long route, or a route project. Yeah, and it doesn't have any pretty pictures. It's more just text, I think, on this one. Yeah, so the point I'm doing there is the second dot point at the bottom, which is to, we can't see that. It's not displaying there, Kathy. If you can just scroll down a little bit. Yeah, so that's it. So produce separate matrices for each logical section. So you try and find homogeneous sections and you chop it up accordingly. The one above it is what my colleague Chris Hall loves doing, because he loves an 18-tab spreadsheet that goes berserk with weighted averages and the like, because you could, in theory, do weighted averages on all of these to bring it back to an individual score if you absolutely must. But my worry with that is that if people don't do that properly, you actually can hide deficiencies in an intersection by combining it with a really good intersection and getting an average, if that makes sense. To come back to what is the intention of a safe system assessment, and it's to flag things that don't align well with safe system principles and to rectify them. And if we use the trickery of numbers to average things out, it's not a good outcome.
The trickery of numbers, hey? Okay, so for Walden, does he need to do 2 matrices?
For the safe system assessment assignment?
Yeah.
No, you can just do one of them. You could just pick one of them. We'd be very comfortable with that. If you said, we're in the bit when it says scope of audit, you just said, or you could do a snip of your design, or you could say, have done this intersection and lead in.
Right. Are you concerned about weave issues where 2 intersections are within close proximity?
Potentially. And if you get in those scenarios, you can either attribute that to one of those 2, or you can do a third matrix of the mid-block section, which would be a bit weird, but if it was a big, massive project, you might. Like we did the safe system assessment for Northeast Link, which is a small little project happening in metropolitan Melbourne, for those who know of it, of costing $12 billion. I think it's 12 billion now. It's just it's Australia's biggest road project ever or something like that. We did, for the, whatever it is, 7 kilometres of road plus changes, I think we did 48 matrices and graphs, because we just needed to chop it up into homogeneous logical sections in order to be able to flag the areas that have specific things that aren't aligning well with safe system principles. I mean, imagine doing one matrix on that. Like, you'd lose any nuances. So in that case, in some of the complex merge weave scenarios, we do a mid-block where you've got, there's one point of that road that's got 22 lanes wide, as sort of 2 freeways meet and a tunnel comes out, and like you just go, right, we're taking this mid-block section and we're analysing it. Now, intersections comes out at a 0, all right? But it's not about that. It's about, really unpacking the other ones. Yeah. Okay, David's asked another question in there. What if the volumes were different? Well, you just take whatever volumes whatever volumes are exposed to the particular crashes, which is usually the higher one. So, I mean, if you had a massive amount of your vehicles turning, for example, they're still exposed to intersection crashes and the like, but the likelihood of it's less because it's one particular crash type. So you would take the higher volume, if you've got very low volume coming in there or something like that, because they're going to be coming out here as well, aren't they? Okay. Thanks, Kathy. Now, how are we going on time? We're going to take a break at some point. It's probably a bit early for that. I'll plow through a little bit more, and I still do want to hopefully, finish a little bit early so people have time to get stuck into some stuff. But I'll cover off a few more things. Okay, the benefits of a safe system assessment. Well, you saw there some numbers in terms of that evaluation, and anybody who would like a copy of that evaluation report, just email through, we can find that. Or it might have even been put in the learning management system, I'm not sure there. A way of determining how well a project aligns with safe system principles. So it's great, like we've craved that for a long time. Safe system principles are fairly fluffy, high level principles. I mean, we need something to, be able to measure against these. It's a method to compare project design options. That's great. Information on changes that will move a project closer to those safe system objectives. A method to assist planners and designers and project managers to take this safe system, as I said there, from fluffiness to practice, and a sound basis for future planning and design of road infrastructure. Okay, let's talk about sort of the process you'd go through, be it as a local controlling authority, so a local government, or a state government, state controlling authority, or different project managers or the like, and then where the safe system assessors can interject. So you see here that safe system assessments are best served early in a project. So we go concept, draft, details, build, open it to traffic. Okay, the earlier we can do it, the better. Why? Because people are willing to change their project at these stages. They are not willing to change much at this stage. And when you do a safe system assessment on a detailed design of a big project and tell them that you suggest they alter their intersection forms completely, they ain't happy. And in fact, they don't do anything with it, or tell you to shred old copies of that report, because we never want that seeing the light of day, because we have just done all of our detailed design. Although we're willing to change a minor bits and pieces. Road safety audits, though, work better there, because they sort of just the nature of how they're presented can and what they look at can often be much, much better at these later stages. And the difference between a road safety audit and a safe system assessment, this has, I think I'll put a little disclaimer in here. I think it's got significantly better after we released the 2022 version of the Australia's Guide to Road Safety Part 6, which integrated a whole lot of stuff in. But I still say that, okay, both road safety audit, safe system assessment, great job, likelihood identification. Severity, road safety audits only sometimes. Now, it's sort of integrated into road safety auditing. However, in practice, it just doesn't work sometimes. And the absolute classic is that set of traffic signals on a high-ish speed road, 70 or 80 kilometre per hour road. And the road safety audit at no point mentions the scenario of people running the red light and the impact forces that we're trying to handle. Everything in the audit is associated with sight lines to the signals, advanced warning, phasing, timing, these sorts of things, trying to ensure that everybody has the best opportunity to see and react to the signals. Hugely important stuff, but missing that one of, okay, now somebody didn't. What do we do? How does that, what's the forces? Exposure as its own entity doesn't occur in a road safety audit. It's packed into the likelihood. They provide recommendations, both of them. They consider all road users. The safe system assessment really hones in on the fatal and serious injury crashes, where an audit will often take into account more of the other injury and the like. And then you've got these wider investigations as part of a full safe system assessment where you look at the vehicles, the people. You can even look at things about maintenance, post-crash care. And recommendations to fundamentally change the project if required. And this last one to me, I still think is one of the biggest benefits of a safe system assessment is that it facilitates innovation. A road safety audit can hamper innovation. It shouldn't, but it can. And that's because, and I mentioned this in module 2, when somebody's doing something new, different out there, the road safety auditor's role is not to quantify or tell them how much improvement that will have. It's to tell them everything that could go bad and all the risks associated. And so the report comes back in a naturally negative way to say, issue, 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 issue. The safe system assessment is fronted up with a graph, and it can show that you have massive savings here and better alignment with safe system principles. And then here's a few recommendations to alleviate some of the concerns we might have. It's just a very different way of presenting that. Okay, a process that we can go through here. Well, this is the common process of how a safe system assessment happens. So first of all, somebody, and I'm going to say client here, and that could be, a road authority or the like, they decide that they want a safe system assessment done. Sometimes there's a policy or a strategy that demands that, as I showed you earlier. And they decide, are they going to do a full safe system assessment or a rapid? And I will take you through the difference between those shortly. You're currently doing a rapid safe system assessment. A full one just has a little bit more to it, not a huge amount more. So the client, and maybe the designer as well, they select the safe system assessment team. Usually if they find a nice independent team that knows, this process, it's completed this course, and then they appoint them to do this assessment. They have some sort of commencement meeting and handing over of information. They give them the designs, they give them the project background. This is usually a combined thing. They ask lots of questions about the project. Why are they doing it? What's this? Have you got future growth? Do you know numbers of pedestrians and cyclists? Are there any schools in the area? The list goes on. That's often done in a workshop or the like. And then there's some inspection of the plans and then the inspecting of the site by the safe system assessment team. Completion of the matrix that you're currently doing, the big table with scores and everything like that. Consideration of other elements of the safe system, those qualitative questions that I went through last module at the end there. If you're doing a full safe system assessment, you go through those. Identify treatments to improve safe system alignment. So you come up with your recommendations, say, okay, your plan was that, and we suggest you add this and that to it. It's all written into a report, and there's standard template reports available, and you're using one at the moment. And then that's handed over to the client, and they then respond to your suggested changes. Yes, we can do this. No, we can't do this. They don't need to respond to you as a safe system assessor. We like that. We like it to come back and the like, but it's really, at this point, you've done your job. That's over to them. They've received an advice report, and it's up to them to decide what to do with all these recommendations, suggestions. And they agree to some of them, and then they should change their design and their project to incorporate the ones that they've decided. So that's the process. Generally, probably a good time just to check if there's any questions at this stage, before I jump sort of into a little bit about sort of guidance and registration and the like.
There's a comment here about, I'm not sure if I'm understanding it right, suggests that the makes recommendations is sometimes for RSA pending, who the client or road authority has requested.
Yeah, I'm not 100% sure I follow that. Yeah, sorry, actually, I think I understand. So New South Wales doesn't do recommendations in road safety audits. They're the only jurisdiction that does, and everybody else makes recommendations as part of a road safety audit report. New South Wales just doesn't do that. So that may cause some of the confusion around who's asking for it, which road authority.
And then David's coming with, as designers in transport anyway, we will get asked on treatments.
Yeah. Okay, good. I'm going to do a few more slides and then we'll have a break. And then I think, as I said, I'll be able to give people some time to finish off quizzes and really get stuck into that safe system assessment. Okay, so a couple of jurisdictions have official registers and accreditation schemes and pre-qualification schemes for safe system assessors. Victoria does. It's on the Safe System Engineering website, and they've got a safe system assessment section. It's actually where you get the guidelines and the template documents and the like. But they have this thing they call a register of recommended safe system assessors. And how do you get on this list? Well, you successfully complete this course to start, and then you do an actual safe system assessment. Now, the mock one you're doing doesn't count because you don't have a real client, you haven't collected a lot of, background context and information and the like, and you haven't, gone through the full process and written up a full report. But you've done pretty well. So you do that and then you submit it, and they actually review it. And if they believe you, have proved that you understand the process and you're able to identify things, they put you on to the list. So that's all there, and then they just publish the list. It's that one, isn't it? The register, and it's just a big PDF of people and contact details who are recommended safe system assessors. So you can get yourself on that if you would like. So South Australian government has gone with something slightly different, and it's a little bit easier to get onto theirs because all they require is a certificate of successful completion from this course. That's all. So you submit that certificate, and they have a list as well, and that will get updated occasionally. So you just send it through, and you will be put on. If you want to be, and they call it a pre-qualified safe system assessor. Now, other jurisdictions don't really have anything at this stage. I think they keep looking at it, and they've decided not to go with that.
Or watch this space coming soon.
Yeah, maybe.
So New South Wales, Transport for New South Wales doesn't have one?
No, they don't. They have a register of road safety auditors. So our road safety audit course qualifies to get onto that register, but there is nothing for safe system assessors in New South Wales at this stage.
Do you have to do a site visit, or can it be done by desktop? For a safe system assessment?
So in a rapid safe system assessment, under the Victorian and South Australian guidance, it says that you may not have to do a site visit. Okay, full safe system assessment, yes, and common practice is that you usually always do, but it is sort of written in there that you could do it without. Now, there's no mention of any of that in the Austroads document. It's higher level than that sort of specifics.
And a question about how investigates the impact on maintenance is handled within a safe system assessment? Have we looked into this as yet?
Not really. So, and it's not necessarily, I should clarify that in the slide. It's not necessarily, is this project going to increase maintenance cost, as in, is the pavement incorrect? Is it, the vegetation going to need more trimming? It's more of that questioning around the facility has been built, can it be safely maintained? And it's embedded a little bit in some of those qualitative questions. So you think about the operation of the new facility, not just in the road user common sense, but if there's potholes, how does the maintenance crew fix those safely? Can they divert traffic around? Have we, considered the ability for that to happen? And so that's sort of that wider qualitative thinking around that sort of stuff. That's the main one it seems to have come up in, is around putting in continuous barrier systems, barriers in narrow median, flush narrow medians, and how do you do and cater for those maintenance activities and not put the workers in danger, but also not put the travelling public in danger as well when those activities are happening, be it fixing potholes or the like, or fixing the barrier system when it's struck. There's another bit that's come in on that. So the difference in maintenance requirements between a wire rope safety barrier systems and a Type F, being a concrete barrier system, that's not taken into account, because that's more of that whole of life cost of treatment style stuff. I've got some interesting information on that, but it's not entwined in your safe system assessment. You may factor a little bit of commentary in to talk about the fact that an F-type can take a lot of nuisance hits and doesn't need the repair crew out there as much, but not from that just dollar cost perspective, impact. That's not part of the assessment.
Next question is, what's the biggest assessment you've completed and how much time did you spend on it, Ken?
Well, yeah, as I mentioned before, it was the Northeast Link. It's an anomaly. It is so big that it doesn't make sense. But it took us about 3 months, and there were 3 of us working on it in different part-time style allocations. So, and then we even pulled in 2 subject matter experts to run workshops as part of it. It's a kind of different beast. Because most safe system assessments are done in a couple of weeks. So it's a simple 5-kilometre bypass. Well, I think that there's probably about 2 or 3 days desktop work, and then you field investigations for something like that. Reporting it up and using the making graphs and explaining your information. But generally, we've got safe system assessing into a fairly similar resource effort requirement as a road safety audit. It might be a little bit more, and my suspicion is it's a little bit more because there's far less safe system assessors out there, so the market, market supply demand is dictating that slightly higher price than on a safe system assessment at the moment. But yeah, that's about just pretty much about what a road safety audit in terms of effort.
Let's see, something within safe system assessment for the continuous barrier, particularly on roadsides and narrow median situations, as this is always one in the conversation surrounding risks for maintenance type activities.
So again, because this is in the qualitative answers at the end, it's really that it mainly occurs. You just sort of making commentary around that. I mean, I've spent quite a bit of time with maintenance crews as we design and develop up these narrow flush median projects, and they can get pretty concerned about it, and I think that's fine. But the reality is that we have far better control over the operational procedures of maintenance activities, the equipment we can use, and the way we can manage traffic under these scenarios, as opposed to not having a central barrier system in place. And we have pretty much zero control over the traveling public and all of their mistakes that happen. So it is a bit of a case by case. There are some good operational procedures that have been developed by some of the jurisdictions on how to do this. There's some great maintenance videos for central barrier systems, which I can point you out. New Zealand's got a series of them, which is good. So yeah, something to consider. But the safe system assessment often shows, well, we're going to go from this high risk area to this low risk area by putting this in, and those are some of the issues we need to deal with. We're not going to compromise this massive reduction in trauma to our community, and we're going to change the way we do maintenance activities to ensure that we can do this safely. I think it's a coffee time, Kathy.
For sure, Ken. Good idea. How long? 5 minutes.
Just trying to think how much I've got to cover. Yeah, let's take 5 minutes. 5 minutes. Okay, we talked about Queensland having a road safety policy that sort of mandates safe system assessments. That's in there. I wanted to mention the VicRoads, or Victorian Government Corporate Requirements, which are the same as the South Australian Government Corporate Requirements around safe system assessments, which says anything under $2 million can have a rapid safe system assessment if it's been deemed that a formal safe system assessment is required. 2 million to 5 million, this is total estimated cost of capital works. It has to have a full safe system assessment for anything complex or any project with significant risk of fatal serious injury, which is going to be anything high speed or anything that's innovative. Rapid safe system assessments for low risk of fatal serious injury, lower speed environments, low volume and the like, and repeat assessments. If a big assessment's already been done and you're doing a assessment on another design option or something like that later down the track, it can be a rapid. Above 5 million, full safe system assessment on all. Only a rapid if it's that repeat assessment. And so what is the difference there? And I said they're kind of not hugely different, but let me take you through that. So I think the easiest way to do this is to talk you through what's in a full safe system assessment and then sort of cross out things if under a rapid you wouldn't need to do it completely. So commencement meeting as such, well, that's one which can be, I'm going to dot cross it out because, a lot of safe system assessments, you do that anyway. It might be a Teams meeting, it might be the like, but sometimes the rapid safe system assessment, you know your client, they know and they know what's happening and everybody's on the same page, and it's just, there's the information you need and off you go. Project background and context, well, you're going to need that in all. The workshop and, that's sitting around and really nutting into the details, that's kind of optional under both scenarios. But it's very kind of rare that it's a big formal workshop in a rapid. Site inspection, again, I sort of dot cross that out. So You then do the existing conditions matrix and all the design options in both. You don't do those other qualitative questions under a rapid. You do make recommendations. You do a safe system assessment report, a rapid or a full. There's just a little bit less stuff to fill out in a rapid. They still consider changes to be made, ideally advise the team and amend the scope. So you can see there's a few things that can drop off. I say about 75% of the work and the resources when it's a rapid as compared to a full, about that. Okay, so the last thing I want to do is just touch on different road environments and what would align well with safe system principles. So why do I do this? Well, the reason I do this is you have been given one site to do a safe system assessment on. You did a bit of a look at another intersection yourself, which was great. But when we give you a certificate of successful completion, it doesn't say, you know, you have successfully completed and can do safe system assessments on minor road intersections or on arterial road intersections. It just says you can do safe system assessments. And that could be on a motorway, it could be on a local street, it could be on a new cycleway, it could be on a public transport project, it could be in a shopping hub, it could be on a high-speed rural road. Okay, so I just want to finally just touch on a few things we know about some of these road environments. I'll do this relatively quickly. Again, just little snippets of insight. Might ask you a few questions on one or two of them just to give out some of those final prizes Kathy's been hoarding. And we'll go from there. So I'm going to cover off residential streets, shopping strips, mixed-use arterials, low and high volume rural roads, outer suburban arterials, and urban freeways and or motorways and major rural highways. Okay, so residential environments like this one, I mean, we really recognize there's low movement requirements through here in passenger vehicles, thus we can blanket speeds down, local area traffic management, looking at exposure. Do we need access to these areas? Can some of these be blocked off from that access, lessen the exposure, so less vehicles through there? Local area traffic management is really key. You know, things like removing parking to open up sight lines can induce higher speeds, so be cautious of that. Removing car parking to give, you know, more bike access or extend out, you know, nature areas is great, but just be aware of that sort of stuff. So lower speed, getting vehicle speeds lower and trying to reduce the exposure of vehicles. Let's go to this one, and I will give out some prizes here. I mean, these are your really high place value areas. I'll give a prize out for somebody who can tell me where this is, and then I'll give prizes out for people who can tell me what could we alter here, and would it influence exposure, likelihood, and or severity. It is Bondi Junction. Well done, Timothy. And so I think it's currently, or in this photo, I think it's like 50 km/h through there, which is quite, but that was a while back. Okay, so seeing raised platform as an idea, and that would reduce the likelihood and severity of crashes. Lower speeds, yep, down to those 30 km/h. Formalised locations for crossing points, potentially, yep, depending on what you're doing with the area in terms of, you know, trying to continue to offer that permeability of pedestrians and the like. But yeah, I think people are starting to think along the right lines there. The first question would be, why are we even having vehicles through this area? Are they needed? Can we block it off? Can we make it a mole? Can we make it a shared zone? Then you're into these major things to reduce vehicle travel speeds. And then maybe if you really determine that it must be vehicles must be going through there, then you can have some big and frequent pedestrian priority crossings with raised treatments and the like. Get into some challenges on these roads then when you have these mixed use arterials, I call them. And these are the kind of roads where you seem to have priority for everything. It's a vehicle priority route, it's a cycle route, it's a public transport priority route, it's a pedestrian activity area, everything's going on. And we talked a little bit about this with our artistic impressions earlier. But again, it's going to involve vehicle speeds coming down, because if we do have that major activity centre, we have pedestrians crossing and the like, it's going to need to have vehicle speeds down to account for the severity of crashes. And you can raise mid-block crossing points. I mean, raised crossings here is raising this is a really good thing. Now you might do it with some particular curbing to separate out the bus facility if you don't want it raised for some reason, or the like. So there might be some alterations. But one of the reasons that's good to do these raised intersections and raised crossing points on these roads, even though they're high traffic routes, is because it's a straight, fast run, and it gives people the opportunity to put the foot down and do that at 10 at night, 2 in the morning, or whatever it is. And you're probably going to have intoxicated pedestrians and things moving through the area, and it's just not a good combination. So the other thing I like to do is a sort of rest on red / dwell on red scenario, which is at night, on Friday night, Saturday night, and the like. I mean, you just phase your traffic lights for their default position is to be red for traffic. So usually that would just sit on green for traffic until a pedestrian comes up, pushes the button, and they wait a bit, and then they cross. When it goes. Dwell on red scenario sits that during Friday night, Saturday night, or times you've got intoxicated pedestrians, you've got all sorts of risk factors going off the charts for pedestrians, and it's not a major need to pump heaps and heaps of traffic through here very quickly. You just phase it to sit on red, and it changes basically when a car comes up and triggers the loop. So they'll come up and they sort of slow down and virtually stop, and then it goes green for a little bit and then goes back to red. And so it just flips, the way that they've been operating. It makes it annoying and slow to drive through this area, and so be it. It's not a priority to get people using this at those hours. Low volume rural roads is a highly problematic one, because we just have hundreds of thousands of kilometres of high-speed, low-volume roads across Australia and New Zealand. It's going to be a challenge for us, because we certainly cannot afford to put the infrastructure in place to have high speeds safely and well aligned with safe system principles, which would involve continuous barrier systems down the middle of the road and the outside of the road. So where we sort of arrive at is that we have to look to manage speeds on these roads usually. And we need to sort of think about how we do that from a strategic perspective. The first thing I think, though, we do in the interim is to think about what are all of the factors we can do to reduce the likelihood of crashes in these areas. Sealing shoulders, audio-tactile edge line, audio-tactile centre line, good warning of intersections and the like, opening up sight lines. So there's a whole lot of good likelihood reducing factors which can still be done. Then we can do some severity factors at highest risk locations, barrier systems for trees close to road and the like, side road activated speed limits for intersections and the like. But then we will inevitably need to get ourselves in a position to start to question the speed of travel on these low volume roads. Community sentiment on this will be varied, and we need to be strategic in how we do it. Now, there will be the emergence of point-to-point mobile point-to-point speed cameras, and they'll be able to be deployed, so you can put them on any road at any time, and that would be a significant advantage. Yeah, I think these will be one of our big challenges going forward. The higher volume rural roads, like this one, it doesn't look high volume in this photo, but it's not good to stand in the middle of the road when there's lots of vehicles around. These are the ones where the infrastructure investment will take place. Central barrier system in a flush narrow median, outer barrier systems, and then at intersections, and major intersections with roundabouts, could be compact roundabouts or the like. You've got a central barrier system down there. You can collect a few access points along the journey so they can use that as a U-turn opportunity. And that's a really nice, well-aligned, safe system style setup. High volume outer suburban arterials with the major traffic route function. We need to really start acknowledging that major traffic route function, if it is what it is, and not try to combine it with lots of other things going on. Certainly, mixing of vulnerable road users with their lanes like this on 80km/h roads is a no-go. Separated bike facilities and pedestrian facilities. And we are within our ability, or we should be suggesting measures to really restrict pedestrians crossing these areas, replacing things like bus stops at appropriate crossing points. It is not a place. Like, this does not have place value. This is a movement corridor, and so we should be accepting of removing of things that add to place value, which is permeability, ability to cross in lots of locations easily, to be there. We do want to think about intersections and raising intersections and slowing vehicles through those points, but we're starting to move it more to like urban motorway style thinking. And motorways are really, they perform really well from a road safety perspective the majority of the time. And they have good alignment with safe system principles because we don't have intersections. The intersections are these on-ramps where vehicles are at speed. So our delta V, our change in speed in crashes is low. They have continuous barrier systems, good lighting, well designed geometrically. They've got, most of the time they've got shoulders, but sometimes that gets eaten up for traffic. But the time where these don't perform as well is as flow breaks down. So when they're free flowing, they perform really, really well. When they're absolutely stuffed, like clogged, saturated, not moving fast at all, there's not enough speed for death and serious injury. We get lots of minor scrapes and bumps. It's as they've got speed and the flow starts to break down. And so really the frontier in these areas are your managed motorways, which is, your gantries over the road, and your lane use management system, your on-ramps having metering, traffic signals on the on-ramp, letting vehicles out. So the lane use management system gives you the ability to use automation or other means to identify things like a flow breakdown coming up, proactively drop the speed down, warn of things. And so you'll see those deployed out on most motorways. And I mean, it's already out there on a lot of them, but it'll continue to roll out. And finally, major rural highways. And this one, we really see, so Pacific highways, the Hume, and the like, they're just going to get, if they've got a wide median already, continuous barrier systems through a lot of it. If it's, if it's being duplicated, it won't be duplicated with that much. It's just going to be duplicated with enough to get one barrier system down the middle and maybe some area for a car to maybe pull over. But even though you can sometimes not use that and just have the left pull over. And at the intersections, grade separation, of course, that's going to remove the exposure to crashes. But if, you've got minor ones and you really can't close them off and divert them to there is sort of one way you can do it at highly aligned safe system principles. Knock that up a little bit. And this will be the last thing I think I'll say. Kathy, you'll be able to show them how to finish the course in a second. So if you have that sort of road with a median like this, and you got this intersection, that high speed 110 km/h crossing of that road is just unacceptable under all of our safe system thinking. So you close that off, and then you provide a long acceleration lane, and then enough space to, get over to the other lane, then an acceleration lane back in the median, and then enough space to get over, and then they can turn back down there. So it's really a acceleration up here, get your delta V's within range, your change in velocity between the entering vehicle and the vehicle that's coming along here. They come back, you get your delta V's the same, and they can make their choice. So that's if you don't want to do something that significantly impacts the through traffic speed. So often on like this one, for example, is the Hume. There was a lot of reluctance to things like roundabouts or anything because major freight route and lots of vehicles, and they didn't want to have to slow down every time they came to an intersection with a roundabout or something like that. So that's the sort of option to accelerate them up and have that alteration, which does align quite highly with safe system principles. Okay, I'm not going to do extra content because I have 7 days worth of other stuff to talk about, and I wouldn't know where to stop, Kathy.
This is true.
It is true. I will take any final questions. I will let you, Kathy, just explain how to finalise the course, and then I'll just do a final statement at the end.
Beautiful. Could you tell us what your thoughts are on maximum speed for roads with roundabouts? Is 100 kilometres an hour okay?
Yeah, absolutely. A properly designed roundabout can be at any speed limit because you use the geometry of the road to slow you down to appropriate speeds through the roundabout. So a lot of jurisdictions don't put any speed limits around their roundabouts. Certainly Victoria doesn't. I don't think South Australia does either. You simply use reverse curves on the approach to the roundabout, so like a chicane, to slow vehicles down to that appropriate speed. Or as we did in Lance Creek, bit innovative, you can use vertical deflection. So that comes off a 100 km/h road, really. And there was a speed limit reduction associated with that. But in theory, you do it off a 100 km/h road and you slow vehicles down using the road geometry, not a speed limit.
Thank you, Ken. Very good. Okay, so I'm just going to share a couple of things just to remind everyone. You just still need to do your safe system assessment report, and it's here in the module 4 section. So you've each got a design, you've got your template, your graph generator there, and one person's already submitted. So hats off to them. Very good. But you do have till next week. So the document you're doing is this one here, which we ran through quickly last time. You update the highlighted sections only. We've provided you the whole template, and that's just so that you're familiar with it, you know what it looks like, but we're not asking you to do every single bit of it. So the crossed out bits are just there for you to be able to use in the future. But for the purposes of the training exercise, not so much. So remember, you've got to pop in a little short thing about the proposed works, the speed limit, a snip of your design here, and then you do your matrices for existing conditions, fill it all out, multiply, add, copy, paste, and then you do one for your design option one, and you will only do it for one design option. And there's some examples in there for you. Update all this. Make sure you get yourself a selfie when you're out on site, like so, to add in at the end. And then you're also looking for those primary treatments and supporting treatments. So you're going to make some recommendations here about what treatments that could be considered for this particular design. And that was the information in the Safe System Assessment Framework. There's some ideas in there for you. So you do all this, save as a PDF and submit through the learning management system in here by next Thursday. And then we'll spend some time marking them after that. And once that's all done and you've completed all your quizzes as well, so there is a very short quiz for today, then you can jump into the feedback and certificate section and you give us some feedback on the course. So a very quick multiple choice style quiz on the course, and then your certificate will no longer be restricted once you've completed everything and your stuff's been marked, so you can download a copy of your certificate there. We'll also send you a hard copy in the mail, as well as any prizes that you've won along the way. And I think that's everything. Does anyone have any questions on that?
Thanks, Kathy. Well, while we wait and see if anybody does want to ask any final questions, I'll just take this opportunity to thank you, Kathy, and your team for all the background work in getting this organised. Yeah, it takes a lot of effort to put these together and make sure everybody's got the information they need in their packs and the like. So thank you. Thank you for your effort there. And then I want to thank everybody for taking time out of their busy schedules to do this course. I think it's really important that we look for new ways to try to ensure that we're getting the most lives saved and the most serious injuries prevented in new road designs or in existing road environments or the operation. And I think this is a really great tool to do that. And I want heaps of people out there doing safe system assessments and using it, and it just being injected into all projects of different natures out there. So you've got a great opportunity. You're in the front pack on a thing that is now starting to be actually required by jurisdictions, that it has to be done. So you'll be able to get in there and assist and help and do safe system assessments for clients, or if you're in road authorities, be able to offer it to other departments or encourage others to get it done, and really promote safe system assessments, promote people doing it, because we know it adds value and it adds that extra pressure to a project team to strive for more safety outcomes that can be done. And yeah, I just think it's really important, and I think that you should be, proudly tell people that you are a safe system assessor, and get out there and be the voice of safe system in all projects. So thank you, and of course keep in contact with us if you've got any questions, or if you want examples of things or the like. Always happy to share whatever we can to help you. We do encourage you to let others know about this course. If you think others would get value from it, feel free to post your certificate on social media, and love it, on LinkedIn, to tag me in, or the Safe System Solutions or the like, and let others know that you've got these skills, and we'll promote it as well. So thank you very much, everybody. Thanks, Kathy. Any
Thank you,
final?
Ken. And no, thank you for your passion and your ongoing enthusiasm for safe system assessments. It's very good. Oh, we're getting lots of claps here. Oh, that's nice. Or maybe it's just one person pressing it over and over again. But thank you very much to the group. You've been marvelous and very participatory, and it's been terrific. And as Ken said, yeah, make a TikTok video. I think that's what you were suggesting. Yeah.
Okay.
Yeah.
Okay.
Or you'll
Well,
make
how about you use
video.
your last 20 minutes here to really get stuck into that safe system assessment so it's not hanging over your head?
That's a good idea. And send me an email, get in touch if you need a hand.
Thanks, Kathy.
Thanks, Ken. Thanks, everyone. Bye.
Bye.